Welcome to Ask and Learn.
All right, so here we are given an is equal to 2 times an minus 1 plus n plus 5. Okay, so part A says that an being equal to capital A times n plus b needs to be the solution of what we have above. Okay, but this implies that an minus 1 is equal to a times n minus 1 plus b. Okay, so we can note then that 2 times an minus 1 plus n plus 5, which is what we have an being set to, would then be equal to 2 times a times n minus 1 plus b plus n plus 5. Okay, well this is equal to 2 times a times n minus 2 times a plus 2 times b plus n plus 5, which can be rewritten as 2a plus 1 times n plus negative 2a plus 2b plus 5. Okay, now this needs to be equal. So we started with something that's equal to an. So this needs to be equal to an. And an, of course, is equal to a times n plus b. So if that's the case, if this needs to be equal to a times n plus b, then 2a plus 1 needs to be equal to a, and negative 2a plus 2b plus 5 needs to be equal to b. Okay, so to reiterate that, that's 2a plus 1 needs to be equal to a, and negative 2a plus 2b plus 5 needs to be equal to b. Well, if we solve the first equation for a, we get that a is equal to negative 1, right? Because if we subtract a from both sides, we end up with a plus 1 is equal to 0. Then we would subtract 1 from both sides. And so now we can put this a is equal to negative 1 into this second equation here. Okay, and so that would give us 2 plus 2b plus 5 is equal to b. And with a little bit of algebra, we get that b is equal to negative 7. Okay, so now that we have a is negative 1 and b is negative 7, then we know from our particular solution that an, the particular one, being equal to a times n plus b, must be equal to negative n minus 7. So that concludes part A. Part B, we are looking at the roots characteristic equation. So here we have an is equal to r, an minus 1 is equal to 1, and all other functions are considered 0. So when we're looking at the function, an is equal to 2an minus 1 plus n plus 5. This n and 5 we consider 0. When we make our substitution, we end up with r is equal to 2. Okay, so that means our homogeneous solution, the homogeneous version, is going to be equal to some constant times 2, our root, to the power of n. Okay, and so we have our homogeneous version. To get the full solution, we want to add the particular solution from part A. So that means an is equal to alpha times 2 to the power of n minus n minus 7. So here we have the homogeneous portion and then the particular solution from part A. Okay, so that was part B. Part C then is to solve it once we have an initial condition. And here our A naught is equal to 4. So we want to evaluate an being equal to alpha times 2 to the n minus 7 with this initial condition. So if we put a 0 in for everything, then we get that for, not for everything, but for the n's here, we would get that 4 is going to be equal to alpha times 2 to the power of 0, which is just 1, minus 0 minus 7. Okay, so we get that 4 is equal to alpha minus 7. So that means 11 must be equal to alpha. So we can rewrite this solution with 11 in place of our alpha. So we get that an is equal to 11 times 2 to the power of n minus 7.